Okay, so this is just going to be a quick demonstration video of how to get started with the VRGO chair. And what I've done is I've created the demonstration project, which was also released as a demonstration for new users of the chair as well. We've included a link to this repository, which we'll link in the video description. And this is slightly modified to the demonstration that users get just because we had some paid material, which was a dragon or a wyvern. And I've removed that, so you'll get a slightly different model when you get to the end of the experience. But besides that, everything that we've provided for new users of the chair, you'll also be able to develop with. Okay, so in the project, what we have, the map that you'll be greeted with should be the main menu map, which you have some options here. So we've got two different types of movements. You can move based on where you're looking, which is the head-based movement, or you can disable that and have positional-based movements. You'll then get two options as well, and this has nothing to do with the chair. This is purely whether you want to use a gamepad as your input when you're using the fire button, or whether you have some VR motion controllers, which again you can use as your fire button. When you've selected one of these, you'll then be greeted with a tutorial map, which just tells you how to move around the world with the chair. You get a small introduction to what will happen in the main level, and then you have your weapon which you pick up and will be firing. And this is what the gamepad or the motion controllers are for. Once you've done all of that, you'll load into the main level, which is the cave_map down here. A few things just to mention as well is under the project settings, the way that we've set up the input is for debugging, I have the move forward and move right for the gamepad left. I'll just turn this on when I'm debugging, but we tend to turn this off so that we encourage people to use the chair more when they're moving around. This will also help in relation to the Control Assist plugin, which I'll be going into in just a moment. This helps to ensure that we know that the Control Assist plugin is working correctly. So that's the next thing, is that to have this working, because the chair uses direct input or raw input, depending on what you want to call it, we've needed to use the Control Assist plugin for the Unreal Engine. Again, we'll provide links for this in the description, and it can be purchased directly from the marketplace. So in the BP player, this is where most of the Control Assist implementation is added. There is a debug for the Control Assist, which is up here. I just tend to leave this, and then we can plug this into the event begin play as and when we try different input devices to make sure that that's working. Most of the actual implementation for the Control Assist, though, I've run through a custom function called move, and this is just so that we can put everything under the standard input binding, and this means that when we're debugging or testing for ourselves, we can also use things, as I've set up, the WS, and like I mentioned, the gamepad as well. And we can do all of this through one function, and there's just a few things that we need to account for when you're running the Control Assist or the raw input devices through this. And that one of the things that I discovered was that for some reason, all of the raw input devices that I've tested with invert the axes for some reason. So that's the first thing that I needed to account for. Besides that, the things that we can see over here, this is just controlling the type of movement that I mentioned. Again, that's not specific to this chair or the Control Assist plugin. And we're just quite simply doing this for the move forward and move right input bindings. So inside of the move function, I'll just demonstrate what we have here. So the first thing we're doing, we are setting the X input value. And this will only ever be triggered from the event graph from an actual X input device. We're then getting the direction as usual. Now, the important thing is that we'll be getting this X input value. We do a check here to make sure it isn't equal to 0. Obviously meaning that there is some form of X input, in which case we probably know that we're debugging, so we'll go into the true branch. We'll set inverted back to 1 because we don't want to invert the axes anymore. And we can set the analog value here. Really then, all we're doing is we're driving the normal movement, and I've added a kind of exaggerated dead zone because we found that the chair is quite sensitive when you're moving around. It can feel oversensitive just because your body's in control rather than just your hands. So we've added an exaggerated dead zone here. All of this is then just being taken into account when we're returning the standard out speed and the direction which you passed in the first place, which is just why that's being stored over here. And once all of that's been calculated, really all we're doing then is we're just using the add movement input, the standard Unreal implementation of add movement input, just with our altered values based on whether or not we have an X input device or a direct input device. So that's what happens if you're using an X input device. If you're using a direct input, so the chair or something which will replicate that if you don't have the chair ready to use, I'll also list those devices at the end of the video, and I've included those in the README in the repository as well. But if you have a direct input device, and obviously this is going to return false, so we want to keep the inverted value as it is to fix that for the raw input, the direct input devices. And then this is the first part of the control assist plugin that we'll be using for the movement. And this is polling the axis of our stored HID control ID, or the device that we found that we'll be using. Once we have that, this is actually where the value is being returned. So in a similar way to this value, the axis value, when you're pushing an X input device axis, what we have here is the same thing happening through the control assist plugin for the direct input. So this is now where we're going to store the analog value. And again, we're going to return that analog value, and we'll be using that up here to account for the dead zone the same way we did before, taking the movement speed in and returning this through the move function. And again, just to be used in the input move forward. So that's just how we've made this completely universal, so you can test and build with any type of device. But as I said, we've kind of went along the line so far of removing the X input controls when we deploy this, just so that people don't use the motion controller or the gamepad to start moving around, because you could have clashes. This is purely for testing purposes, really. Now, so that is how the movement's handled when you have the direct input polled into the control assist plugin. And we'll just look at where that gets done as well. So up on the event begin play, the first few things we do is we're setting the control type, and we run off a sequence here, and we're getting the HID controller. So this is all control assist code, and all of this, as soon as you have the plugin installed in just the standard way that you install any plugin in the Unreal Engine, you just simply right click and it will add this into the code selections. So if we wanted to get the controllers, you just type in get controllers, and we can see we have the control assist implementation of get controllers here. So we're going through a for each loop to find out how many HID input devices we have, and we're storing references to all of them. And under here you can get information such as the name of them. So one of the gamepads that I was testing on is the Still series, Status XL, and this is the name of the VRGO chair. We don't actually need this branch anymore at the moment. We can just assume that any direct input device we get will allow this to run. We're storing that, and as we saw earlier, the HID control ID is what we'll be referencing in the movement, or in the move function. So that is this down here. So that's why we needed to store that at the beginning, is that we'll be polling the axis from that control ID. So that is really all you need to do to get a device running through control assist. Now, the other thing I wanted to show is that if I just go back to the tutorial map, inside of the BP_player, we can just link the debug up to the event begin play. And again, this is all control assist stuff, so you can find all of this as soon as you've installed the plugin. And all we're doing is we're adding the controller diagnostic widget to the viewport, as you would any standard widget. And this will just provide information on the devices which are currently available. And it also really handily shows the feedback on what you're pressing. So if I just go back in here and press play, we need to click into the viewport as usual to get the engine to recognize us. And what we can see here is the control assist input debugging. And the really handy thing is it will tell us which axes or buttons are being pressed on the controller. So I'm currently using the Xbox One controller, and the Xbox 360 controller will also work. What I discovered is they natively support direct input. So they default to X input, but if something can detect it as a direct input device, it will automatically translate to the direct input implementation, which is really handy here, and why I mentioned that we want to make sure to remove or turn the axes down to 0, because it would, if we had the standard value of 1 here, then it would default to be the X input, so we wouldn't know this actually working through the control assist plugin. But because we've turned the Y axis off, essentially, we know that whenever this is moving in here, that is purely through this direct input implementation. And as I said, we can also get the buttons as well. So this is really handy to find out which buttons refer to which button presses and which axes. So we can see the triggers are the 2 and 5 axes. We've got the right analog stick and the left analog stick moving. And I've only actually programmed anything to happen with the left analog stick because everything else should be happening head movement wise through the headset. And the button can be standard X input anyway. And that's for firing at least. So this will be a really handy way to debug things, and you can see up here as well, it does say that this is an X input controller, but as I said, the Xbox controllers, the 360 or the Xbox One, will be able to swap over to direct input if required. So they're really, really handy to test this on if you don't have the chair around. So that was really everything. If the controllers that we've worked with and can guarantee work, we've got the one that I've named in here. The SteelSeries Status XL, that works perfectly fine. I've personally been using the Xbox One controller, and we've seen that the Xbox 360 controller works as well. So any of those will be fine for debugging this if you wanted to check your direct input is being picked up correctly. The next thing I'm going to go through is when you build the project, there's something you may need to do at the end of building the project. So you will export the project as usual. You go to package the project, Windows and 64 or 32-bit. You'll get the standard build at the end of this. I've got one already prepared. So this is the build that I got, and what you will find, or what you'll possibly find depending on certain other things you have installed on the system, is that if you have the control assist plugin and you go to launch the executable, you'll be told that the program can't find the SDL2.dll that's missing from your computer. I think this is a clash of some sort with certain installations of Steam from what I found online. And it's quite simple. The way to fix this, again, we'll include this file for you to download and input into the project. Otherwise, I'll just show you where you can find it as well. To locate this SDL2, it's not actually missing, but we just need to nest it in the project. So on your system, in the equivalent place, find where you've installed the Unreal Engine and your current version. So mine is the C drive, and I've got version 4.14. And you need to navigate to the engine, the plugins, the marketplace, control assist, source, third party, and so on. Or you could just search SDL2.dll until you find this SDL2.dll. Simply make a copy of this, and where we need to navigate in the project file, so this is where you've built the project, is go to the name of the project. We'll go into the binaries, the Win64, and then just here where you have the other version of the executable, just press Ctrl-V to paste this in. We can double click to open this, and this will now work. And just to demonstrate as well that it doesn't have to be run from that executable, we can now go back to the original one that didn't work earlier, and this will now work in exactly the same way. So that's the fix for the problem I found with Control Assist and the SDL2 DLL being missing. So that should solve any problems when you come to building the project out as well. And the final thing I wanted to cover, this is exactly the same project, but in 4.15 rather than 4.14. Because I know we'll probably get questions for this anyway, is that Epic have now provided a native support for direct input, or they call it raw input. And we haven't found that this is stable enough yet to actually recommend using. Some controllers which should work completely don't. Some have the axis mappings being returned as button presses for some reason. But just in case you did want to play about with this and trial it yourself, if you have 4.15 installed, you just go to plugins and go to the input devices, and you can go down here and tick enabled the Windows raw input. When you've done that, it will tell you to restart the engine, and then you can scroll down in the project settings and go to the raw input devices. And now what you need to find is the vendor ID for your product and the product ID. And the easiest way to do this is if you hit the Windows key and then type run, hit that and type in dxdiag. So this is the DirectX diagnostics tool. We go to the input. This will give you a list of the input devices you have. And what I should be able to find down here somewhere is my Xbox One controller. So this is the direct input that I was trying to get working, and I just couldn't get this to register properly with the raw input through the Unreal Engine. And likewise, I couldn't get the chair to be 100% functional on it. So for the moment, until this has been updated and made a lot more stable, I think we probably won't recommend this approach for developing with the chair. But if you did want to give this a go, then from here you can get the vendor ID and the product ID. And I can see that this is for another controller that I was trying as well, for the SteelSeries controller. So just put those in the right place, and it will by default give you all of the generic USB controller axes, and all of the button presses as well will be set up. When you've done that, you can then go back into the input commands, and you can try adding in, as you normally would, a generic USB controller input. So as I said, the best I've got so far is the axes are registered, but they're classed as buttons, so you don't get the actual axis control from 0 to 1. You just get either 0 or 1, and there's for some reason no backwards. So I'm just going to leave this for now, but that is an option which potentially may become more viable in the future. And for those of you who are aware that it's been added by Epic in the Unreal Engine, just wanted to mention that we are aware of it. It just doesn't seem to be fully functional at the moment. So that should be everything that you need to know to get the VRGO chair working. And as I said, links for the repository will be included in the description, as well as the Control Assist plugin.